All right, let's get right into it. For years, it felt like all the big AI models were on the exact same track. Just get bigger, get smarter, rinse and repeat. But then 2026 happened, and boom, the entire AI world split right down the middle, creating this massive divide, a real battle between brains and brawn.
You're going to want to circle this date on your calendar, February 5th, 2026. This was the day everything changed. I mean, literally within minutes of each other, Anthropic and OpenAI dropped their new flagship models. And in doing so, they didn't just launch new products, they basically declared two completely different visions for what AI should even be.
And this is the new reality. It's all laid out right here. In one corner, you've got Anthropic's Claude Opus 4.6, which we're calling the architect. It's the deep thinker, the planner. And in the other corner, you've got OpenAI's GPT-5.3 Codex, the execution machine. This thing is built for pure raw speed and just getting stuff done. Now, this isn't just clever marketing, you guys. This is a fundamental philosophical split that we're about to unpack.
So yeah, let's dig into the philosophy, because this is about so much more than just a list of features. What we're really talking about are two totally different ways of thinking about how AI should help us do one of the most complex things there is, building software.
Okay, first, we've got to get on the same page with a super important term, agentic coding. We are so far beyond simple code suggestions at this point. We're in a whole new era where these AI systems are basically autonomous agents. They don't just write a little function for you anymore. Nope. Now they can understand a high-level goal, map out a plan, actually do the work, and then check it over to make sure they got it right.
Now here's where it gets really interesting. Look at how these philosophies actually work. Claude's adaptive thinking means it can literally decide to think harder about a problem. If something's really complex, it'll pour more resources into reasoning it out. Meanwhile, GPC is all about recursive self-improvement. And get this, it actually helped its own creators build and debug new versions of itself. That makes it ridiculously good at the messy real-world work of coding.
All right, so enough with the philosophy. Let's get to the good stuff, the numbers. How do these two heavyweights actually perform when you pit them against each other? Let's check out the tail of the tape.
This spec sheet right here tells the entire story. Just look at the context window. Claude is packing 1 million tokens. That's double what GPT has. But then, look at the inference speed. GPT is almost 3 times faster. It's so clear. Claude is built to absorb a massive amount of information, while GPT is built to act on it in a flash.
1 million tokens. I mean, let's just pause on that for a second. What does that actually mean? It means the AI can read an entire, massive 150,000 node code repository, a whole complex app, in one single pass. It sees the entire blueprint at once. For deep architectural refactoring, that is a colossal advantage. But then you've got this number, around 250 tokens per second. That is the raw blistering speed of GPT, and it's a 25% jump from the last version. For any developer who needs to crank out boilerplate, write a bunch of tests, or just move incredibly fast, this speed is an absolute game changer. It's the difference between waiting and actually doing. And you can see this playing out perfectly in the benchmarks. On Terminal Bench, which basically tests if an AI can use command line tools and manage a file system like a real dev, GPT just runs away with it. This is why we call it the execution machine, or the hands. It is just better at the physical act of coding.
But hold on, let's switch gears to a totally different kind of test. GPQA Diamond. This measures graduate-level reasoning. And here, the whole story flips. Claude takes the crown. This is the architect, the brain. When you're talking about complex, multi-layered problem-solving, Claude is just on another level. The gap gets even wider when you look at professional work. On a benchmark measuring economically valuable tasks, Claude has a massive 144-point ELO lead. So what does that translate to in the real world? It means if you give them a task like financial analysis, Claude is probably going to give you a better result about 70% of the time.
Okay, benchmarks are one thing, but the real test is always how these things perform on actual, messy, real-world projects, right? So what happens when we step away from the clean numbers and throw them into the chaos of software engineering? Let's start with an absolute monster of a task. We're talking about taking a huge, sprawling web application and refactoring the entire thing. This was a 48-hour deep dive test, basically designed to push these models until they break.
And the results are just fascinating. Claude took a full 6 minutes. It entered this deliberation phase to really understand the whole system. But the code it produced? Nearly perfect. GPT, our speed demon, finished in under 2 minutes, but it made little mistakes. It would forget parts of the code it wasn't looking at, which caused errors. It's patience versus speed, and the outcomes couldn't be more different. Okay, so now for the ultimate test. This sounds like something out of a sci-fi movie, but it was a real experiment. Can an AI, starting with absolutely nothing, build a working computer operating system and then run a classic video game on it?
And the answer, unbelievably, is yes. A team of Claude agents worked together and actually pulled this off. They generated over 100,000 lines of code, navigated all these complex compiler tests, and successfully compiled the entire Linux kernel from scratch. And the final payoff? They executed the game Doom. This is just a monumental achievement. It shows a level of autonomous skill we have simply never, ever seen before.
So, what does all this mean for you? For the developers, the engineers, anyone out there trying to build things? Well, the game has totally changed, and that means the playbook for how you win has to change too. And that brings us to the biggest takeaway here. The smartest developers? They're not picking one model. They're using a strategy called tiered logic. Here's how it works. You use Claude, the architect, for that big picture design to solve the really gnarly logic problems. Then you take that beautiful solution and hand it off to GPT, the execution machine, to just churn out all the repetitive code, the tests, the documentation at lightning speed. This quote from one of the sources just nails it. Claude is for the hard stuff, the things that require genuine, deep thought. And GPT is your execution machine. It's for building fast for that daily coding grind. It's all about using the right tool for the right job. And that brings us to the big, final question that's probably on your mind. After seeing all this, the specs, the benchmarks, the crazy case studies, which one is actually better? But here's the twist. Asking which one is better is actually the wrong question. It completely misses the point of this new, specialized era of AI we're now living in. Because the future of working with AI isn't about picking one winner. It's about being the smart conductor of the orchestra. It's about knowing exactly when to call in the deep-thinking architect and when it's time to unleash the fast-moving execution machine. The real power isn't in just one tool anymore. It's in knowing how to wield them both.